dog. So, all right, Olivia.
Oh,
So tell me about your IA. Let's just start there.
okay. So what we're doing is we took tomato plants and put them in little containers. And to add humidity, we like sprayed water to add humidity into it. And we were trying to measure how humidity affects tomatoes and like how fast they rot. Um, I I did pH. Ariam did the temperature of the tomato, and then Patrick did the mass of the tomato. And we just like during a 2 week period, we measured how it changed over that time.
You put you use tomato plants or use tomatoes?
Oh, tomatoes.
Okay, not the plant, but
Yeah.
just the fruit.
Yes, just the fruit.
Okay, so I'm looking at it. You said place two tomatoes because it was a little ambiguous whether you use tomatoes or you use tomato, the actual fruit. And so you're measuring decomposition of tomatoes.
Hmm.
Okay, so did you see those questions that I sent you last night?
Yes, I did.
Okay, so let's deal with those questions real quick. What are your answers to these questions? Let me see what those questions are.
Um, so for number one, we didn't really find a source. Like we kind of just thought of it honestly. We were thinking about how like our first idea was thinking about how like rotting food like affects populations. So we were thinking how about populations with high humidity, and that's kind of where we got the idea. We didn't check with a source. Um,
Probably
for
a probably a really good idea that you do because one thing that you would need to do, it's like um, if have you ever heard the expression what you believe may not be the truth and what the truth is you may not believe it?
No.
Well, I mean you get the point though, right?
Yeah.
All right, I mean there's some people that storm capitals because they think that QAnon is told them to and they think that's right? So we want to try to get away from just going on gut. So and if you're going to write about this, if you're going to write about decomposition, you're going to need to have some kind of source to back it up. So in your background, it's a little ambiguous, and so you really need to beef that up and really discuss what decomposition is. If you're going to measure pH, would you expect a decrease in pH with decomposition? Would you expect an increase in pH with decomposition? Why or why not? There needs to be something in there that supports whatever your hypothesis is. So am I sharing the my screen with you and showing you the questions, or am I
Yeah.
showing you the paper?
Oh, the paper.
So I need to go back to the paper so I make sure I'm looking at the paper with you. So one thing, let me scroll down to your hypothesis, wherever that is. Let's see. Right here. So your hypothesis, you really don't have any sort of scientific cause. You should have an if and then a reason for it. And so you said as humidity decreases, then the temperature of the tomato plant will increase because. So you need to have something up here. I mean, really after that, but whatever reason, because statement, that needs to come from in here. So why would you expect there to be an increase in temperature with a decrease in humidity?
Okay. All right. And then for question two.
No, but
So,
I'm asking the question though. Why would you expect an increase in temperature with a decrease in humidity?
we've researched some sources, and it said that as a tomato decreases, a temperature will increase.
As
So
it
that was
as humidity decreases or as a tomato decreases?
as oh wait, I think we just did it as the tomato like decomps.
Okay. And that makes sense because decomposition is a catabolic reaction. When things break, they release energy. And as that they release energy, then and there should be an increase in temperature. So that could be something that you could write about, right? Because catabolic
Right.
reactions release energy, they don't store energy. So there would be something that you could cite, but you'd probably have to come up here in your introduction and or your background and talk about how decomposition is a catabolic reaction, which should release energy in the form of heat. Something to back this up. Otherwise, you're going to miss a mark on your hypothesis. You got to have something to back that up.
All right.
All right. So let's take a look at your that second question.
So we did it like 20% above the one that's supposed to be 0. That's how we were measuring it.
So you're assuming that the inside of your house is 0 humidity.
Yeah, we should have thought of that. We didn't think of that.
Well, but if you're making that assumption, do you know that the inside of your house is at 0, the humidity is 0%?
No.
Okay, but you did have some sort of instrument in there that did record the temperature, right?
Yeah.
Okay, so what I would recommend then, and I'm going to go back to your paper because I'm looking at the questions again. I'm going to go back to the paper. Let's see. See this you're seeing the paper, right?
Mm-hmm.
This hydrometer.
Yeah.
In your procedures, let's see, where did it say? Here it is. Spray. So it's 20% above the original humidity level for each container. So this is the ambiguous part. When you say original humidity level, I don't know what that means.
Okay.
Neither is the reader going to know what that means. So what I would just say is that at a humidity of 20%, right? Spray the container at 20%. This hydrometer, you also need to put the make and model for that. All this stuff needs to be very specific. So like tomatoes, Roma tomatoes, what was the mass of the tomatoes? So when you're saying 6 tomatoes, 6 tomatoes and have the store that you purchased them at, the mass of each one of those in terms of your materials, the Tupperware, what were the dimensions of the Tupperware? I don't know. Like if that Tupperware has a volume, you need to put that volume in there. I don't think you really need to give the make and model of your tape. Just be specific what kind of tape it was. Was it masking tape? Was it what kind of tape? But the thermometer and hydrometer, you should put the make and model of those instruments. Water, is it deionized water? Is it tap water? What kind of water is that?
Okay.
So if you look at some examples of these IAs, they're very specific. And these are easy marks to get. Because I'm going to be honest with you, your data set is really small. So you're going to lose points on your data. You want to get all the points you can get on all these other things. Also, your variable was pH, right?
Mm-hmm.
So what material did you use to measure pH?
This is Arium's, but on mine, I use like pH strips.
Okay, so yeah, you need to, so whatever yours is, you need to have that. Are those pH strips? What are those pH strips? Where did you buy them? What brand? All that stuff. It needs to be very specific. Okay, what was that other question I asked you?
Another one was how would you have the expected values? What understanding did you have from the research to predict those values?
Yeah.
I don't know, because when because we kind of like split off, like Arium did like the math part, and then I did more focusing on the writing. And when she was doing it, I don't know where she got the expected values, and I was gonna ask her before I got on a call so she could explain it to me, but she didn't get to.
All right. Well, this is your data right here. So let's take a. You do some. I think you have some. You have expected here. So you were expecting at day 1, 4.9 on, and then 4.7 and 4.8. So you're expecting a decrease. You're going from 4.9 as a decrease, excuse me, as an increase in humidity. You were expecting a decrease in pH, and then you get an increase again. That's what I was kind of not understanding. Also, what is this total of?
Yeah, I have no idea because I asked her when we were working on it, and I said, "What do you mean by the total?" And then she's like, "Oh, I don't know." And so she was gonna go back and redo that. And Diaz also asked us that too. I
Yeah,
think
I
she was
don't
just
understand
adding
what that
up.
total it means. The other thing is this supposed to be pH in terms of total?
I think she was just like adding up. Yeah, I think she was just adding up, and she just put those over there. It was probably for pH.
Just adding up for the sake of adding it up?
Yeah, I have no idea why she did that.
Okay, because you realize what is a pH scale?
It's like a 7. Like
No,
it's
no, I
like
mean 7 is neutral. What is the
yeah.
top end of a pH?
Oh, oh, it's a 0, right? Or am I
No, that's
better?
the low end.
And then, oh, 14. I should have
Yeah,
known that.
so like that makes this actually makes no physical sense. There's no place in the universe that there's a pH scale of 14.6, and there certainly isn't one of 197.2. So like
Yeah.
I would lose all of that.
Okay.
I'm not sure what that was. Okay. Yeah, I don't think unless you have an expected value, then the only thing I could say in terms of your expected value, if you were going to use an expected value, I would start off with the starting point of whatever the pH was for that tomato, if you know that. You
Okay.
might be able to write a justification for that expected value in your eye by saying, well, we're going to start with the expected value is that it's going to remain the same, right? It's not going to change. You might be able to get away with that. I don't know whether you could get away with it or not, but you might. Um, okay, so let's go to that other question. Just trying to
Um,
get, these were just my initial questions when I read this.
alright. Um, how do you know there was an anaerobic bacteria on the tomato to achieve fermentation?
Yep.
We did research, and they said like when we did research, we found that out. But I guess we never double checked that it was on our tomatoes.
But you do have research to that does support that there's anaerobic bacteria on tomatoes.
Yeah.
Okay,
So,
all right, all right. Let's go to the second part of that of number 4.
if there were anaerobic fermentation bacteria, was more oxygen removed from the environment to let fermentation. We were going to measure oxygen removal, but we didn't have the device to do it because we realized that could you know, so but we couldn't find the device for so we didn't do it.
Well, let me ask
But
you another question then. So, were the bacteria supposed to be inside of the tomato or on the outside of the tomato?
inside.
Okay, so you could potentially, if they're inside of the tomato, then and you do have research to suggest that that needs to be in your background, right? You need to have that in there anyway, writing about that. And whatever that source is to back that up, because I was assuming that you're talking about on the outside, and if I have that question, the other researcher is going to have that question.
Okay.
You probably also want to write about fermentation and how fermentation works in your background. Okay, and then the last question: did you run more than 2 trials?
No, we did not. We only
Okay,
were able to run 2.
okay, you're able to run 2, so that's going to limit your data that you can analyze. So I'm going
Okay.
to stop sharing my screen now. Oh, I've already stopped sharing it, haven't I?
Oh no, I still see your screen.
Here, oh, well, let me share your data first.
Okay.
So one thing, this would be an excellent way to have the data organized to have in your IA, but you can't really organize your data this way if you were going to actually do any statistics with it. I don't know
Okay.
how they got these. I'm not sure how they got this. I'm not sure. So like, where did she get these 26 degrees of freedom? I don't know.
Okay. I'll ask
Right.
her about it.
Yeah, I don't know. Because do you know what the formula is for degrees of freedom?
No, not really.
Okay,
I
it's
don't know
degrees.
what you used.
Degrees of freedom is n minus one, number of groups minus one. So you have, you ran 2 trials, you had 2 tomatoes for every group. So your degrees of freedom should be 1, not 26. What is significance level? What does that mean?
She set the significance level of like 5%, like if like that was the like overall change, I believe that's what she did.
Okay.
I don't know why she decided 5% though.
I don't either. And a p-value, I don't know where she got a p-value of 100% either.
Yeah.
I'm not sure. Also, if you got a p-value of 100%, you would accept your null hypothesis, not reject it. So
Oh yeah.
you might want to go back and see about that as well, because if you, the only time you accept your null hypothesis, because your null hypothesis says that there's nothing going on, there's nothing happening. So to reject a null, you have to have a less than 5%, not. So if you got 100%, you're going to accept the null hypothesis, say there's no effect, nothing's happening here. All right, so I'm going to take your data. This is how, and I'll tell you where I got this. So if you're going to organize data, you had 2 ways that I could see that you could potentially run this. You had 2 trials at every humidity. So you had 2 tomato plants at 0%, 2 tomato plants, and I put 2. I don't know why I did that. It should be 20. Hold on, let me change that. You can see what I'm doing, right?
Yeah.
All right. You could do it by humidity level. You had 2 trials for every humidity level, and they're going to gig you on that. You're going to lose some points on insufficient data, but you got, at least you got something to turn in. And you need to write about why it was insufficient at the very end. You need to write about that. Why was it insufficient? Okay, day, you could also analyze it by day. And I did it, and also I probably want to do it by hour. I don't know what time of the day you did this. You took your measurements. I'm assuming that you did it at the same time every day, so you had increments of 24 hours as you did it. But I just had day 1. I don't know if that's the initial day, or which would really be day 0. I don't know if this is 24 hours later. I'm not really sure. But what I did is I took day 1, then 3 days later is the 4th day, 3 days later is the 7th day, 3 days later is the 10th day, 3 days later is the 13th day. It looks like you did it for 14 days, but I couldn't get beyond that. So if I did it again 3 days later, I'd have gone to 16. But I was just thinking there might not be enough change between 24 hours, but 72 hours, there might be enough change. I don't know. But then now I have my data organized in columns and rows, and I can actually, any software that you would use to analyze data, your data has to be in columns and rows, otherwise it won't work. So let me show you. I'm going to go to Data Classroom. Let me see. What are you seeing right now on your screen?
The spreadsheet.
And a spreadsheet, or in Excel, or a spreadsheet in Sheets, the Google Sheets?
Excel.
All right, I'm not sharing my screen with you then. Hold on. Not where I want you to see it. Do you have a Labradoodle?
Oh yeah.
Show you my dog. All right. Can you see Data Classroom now?
Yeah.
All right. And you have used Data Classroom, I'm assuming.
Yeah, Diaz went over it in class.
So you can use Data Classroom yourself. Now you can manipulate your data how other ways that you would like to, but I'm gonna play with it just a little bit. Let's see. Yeah. They've changed this a little bit. I had to get your dog out of the way. spelled your name correctly, right?
You're missing an R after the F.
I'm missing an R after the F, so it's Gfrorer.
Yeah.
There's 3 R's in your name.
Yeah.
What is the ethnicity in y'all's names?
It's a German last name.
This is German. Okay. I've never asked that. Huh? Well, she's not. Yeah, I should. You're right. I really should. Okay. Let's see. Let's just I'm gonna put tomatoes. All right, doesn't really matter. All right, I'm going to choose a file. I have you saved under. I think I saved your file under genetics lab. No, not genetics. Just data. Gfrorer. I think I even call it. There it is. And I'm going to save it. Done. Everything. Now, do you see these check marks?
Yes.
Anytime you upload something in a data classroom, it's going to make sure that your data is set up. If your data is not set up for statistics, it's not gonna work. It's going to say, hey, hold on, you need to go. And it'll even prompt you what you need to do. If there's an X there, it'll tell you what you need to do.
Okay.
All right, so here I am. So now I can actually analyze some data. So what was your independent variable here?
The humidity.
All right, so I'm going to change. Is that what? How would you put that? Categorical, numerical, sample, or info?
Numerical, probably. Yeah.
No, it's category, independent variable, independent, dependent. It's just consider this to be a categorical situation.
Okay.
Empty cells found. Hold on a second. I wonder how I have empty cells found. Hold on a second. Don't fill. I guess against pH, it's okay. All right, I'm gonna go back. Category. Unknown. Don't fill. Why is it doing that? Let's try independent variable again. Categorical. Still doing it. It's thinking this over here. Let me. Maybe. I don't want to do that. I'm going to change this. Let me get rid of this. Unknown. Unknown. Come on, buddy. Unknown. It's thinking, the system thinks I want to run it against this day in pH. So I may have to go back and change your spreadsheet to not compare those, but let me try to just do this real quick. I'm just going to try to make a graph on it first. Okay, so humidity category. It still doesn't want me to do that. It hates me. It really hates me. I'll put numeric in there for now. And now let me see if it's not going to let me do it. That sucks. All right, I have to go back to your spreadsheet and change it. I'm going to make 2 spreadsheets. Let's see. I'll copy all this, put it into another one. Cut. Oh, you don't know what I'm doing though. You can't see the spreadsheet anymore, can you?
No.
Hold on. So the problem it's having is it sees these numbers over here, and it wants to compare this side. If I choose this as my independent variable, it's assuming that all these other things are dependent variables, and there's nothing here to compare this number to. So this 40 is going to be paired with this. This 40 is going to be paired with this pH. This 40 with this 20 with this pH. When I don't have it's assuming these are dependent variables, and this is blank, and it's freaking out. It doesn't know what to do about it. So I'm going to take this out. By the way, were you guys working on the Dracula play? Is that what y'all were doing today?
Yeah.
What are you?
I'm the technical director.
What are the when are you guys going to be done with this?
We compete for our first competition on next Friday.
Oh my gosh.
Yeah.
So what's the technical director have to do with this?
handle all the technical aspects of the show.
Like what? I mean, that's what I'm saying. Like, what are the technical
Oh.
aspects? It's a 1-act play, so.
Yeah, because Lily's the lighting person, so I designed all the lighting, gave all the lighting cues, and designed all the fades, and then gave that to her. And then Danielle is the prop master, so I listed out all the props she'll need, and then helped her like gather props as well. And I'm in charge of like sound cues, making sure sound cues go on time, and I'm in charge of making sure costumes are in order and props are in order and set.
All right, well, you're going to be in charge of getting data in order here in a minute. All right, so let me go back to data classroom because it hates my data set. Discard, save, leave. Can you send me back on data classroom again?
No, it's still the Excel.
All right, let me go back. So I'm going to re-upload your data set. I'm going to call it Gfrorer 2. And I'm not going to put a short description this time. Choose a file. Go back to data. I should have 2 files. Let's say Gfrorer now. Where are you? There you are. Don't know which one's which. I think this is my first one. We'll try this. Either one should work though. What's your dog's name?
Lambo.
Lambo. Oh, perfect for Green Bay. Gotcha.
Yeah.
Okay, categorical. It worked this time because everything's paired. Now we're going to go over here to, this is going to be numeric data. This is pH, that's numeric. By the way, pH is lowercase p, uppercase H. You have it as capital P, lowercase h in your paper.
Oh, okay.
That's something else they're going to gig you on. All right, let's run this. Let's see how it goes. Everything looks good, I think. I think it's good. They've changed the website on me since I have done this in a while. Okay. Let's go to graph and then try to do this. So I'm going to show. Humidity is my independent variable, so I need to call this. pH is my Y. Why does it not let me change that? That's X. This is Y. Why is it not letting me do that? Scatter plot. I need to do scatter plot. Now it makes sense. There. Humidity, pH. Not letting me do a scatter plot. Don't know why it's not letting me do that. I'm going to change category again. Info. No, won't let me do that either. There it is. Okay, XY. I don't know why it wouldn't let me do it before. That's weird. Okay, so let's put some descriptive statistics to it. We'll use standard error. And there you go. There is, now from looking at this, which groups are different or statistically different?
The 20.
From what?
They'll kind of overlap.
Yeah, if they're statistically different, they'll overlap. I mean, excuse me, if they're statistically the same, they'll overlap. So
Okay.
what is it different from? Which ones are different?
I don't know.
Well, you can see the screen though, right?
Yeah.
Okay. So where's their overlap? Between 0 and 20, 20 and 40,
Okay.
40 and 0, which ones are overlapping?
0 and 20 are overlapping like a little bit, and then 0 and 40, and then 40 and 20 are also overlapping.
These, they're kind of overlapping that the error bar goes to 4.8 for on the low end of 0, and then it goes to on 20, it goes to 4.8. That's kind of overlapping, kind of not. I mean, they're just barely overlapping at 4.8. You could make an argument that they're not, but from 20 to 40, yeah, there's a lot of overlap right here. Tons of overlap. If I had to, let me see if I can get a little annotation tool. Right, there's tons of overlap right here. Tons.
Yeah.
There's not so much here. That's just basically straight across. I'm going to get rid of my drawing. I don't know though. That's still really kind of a, let's see what they say in terms of statistics. So it doesn't, this isn't enough data to run a t-test. You can't run a t-test. It doesn't, you don't have an expected value, so you can't run a chi-square test. You can run an analysis of variance. So you need to write about an analysis of variance, what an analysis of variance is in your paper, but let's calculate this. And it'll calculate your p-value is not 100%, right? P-values are also never in percentages. They're always in decimal form. So your p-value is 0.46. Notice what it says right here. What does that mean? What does that say?
So they're not like different. They're not
different. What
yeah.
p-value do you have to have for them to be statistically different?
0.5.
Nope.
Oh, really?
Yeah, if it was 0.5 and you were 0.46, you're almost at 0.5.
Oh.
0.5 is only when you're 50% sure you're going to have an effect. You're only 50% sure. How sure do scientists need to be in order to have an effect?
100%. So it'd be 1.
No way. Nothing's 100%. Nothing's 100%. You can't ever be 100% certain.
Okay. Would it be 60 or like 70?
It's 95%. So I want you, let's do a little, let's buy something at the store. So you go to the store and and something costs 95 cents. In decimal form, what does that look like?
0.95.
Exactly. What is the inverse of 0.95?
Inverse?
If you have $1 and you buy something for 95 cents, how much change are you?
0.05.
Exactly. So when you want to be 95% certain there's an effect, if you're 95% certain, how uncertain are you?
Only 0.05.
Exactly, 0.05, 0.05. You're 5% uncertain. So what scientists will do is if they're 5% uncertain, they'll be like, okay, there's something going on here. I'm going to reject the null and assume the alternative hypothesis. So if you're going to have a hypothesis and you're going to have two, and you're going to, in your data set, you're going to say you reject or accept a null, you need to have two hypotheses. You need to have an alternative hypothesis, which is what you actually think is going to happen. And then you also need to write a null hypothesis, which is going to say that there's nothing is going to happen. Have you written those in your labs before?
Oh yeah, we've done them before.
Okay, so anytime you run, then you need to write those in your IA, right? So you can get a point there. Yeah, here there's nothing. Now, part of the reason, and when you run your data, when you run the statistics here and you get these little facts and figures, you're gonna need to write in your analysis that even though you got a 0.46, probably the reason is that you got a 0.46 is that you only had 2 trials. You really needed to do this with about 30 to 40 tomatoes in each group, like 30 to 40 tomatoes in 0% humidity, 30 to 40 tomatoes in 20, and 34 tomatoes in 40. Unfortunately, you've got 5 days.
Yeah.
So I don't know how you do that now. You might be able to pull it off if you can do it in the next, maybe run run all those trials and do it and collect data today and then collect data on Wednesday and then write all night for on Wednesday. I don't know, or on Thursday. I'm not sure. Do you know how to take images from this?
Uh, no, but I could probably just like screenshot it.
No. See that little camera thing I just clicked? Look at that. See that
Yeah.
thing? Watch that. I clicked that. Now, before and when I do that, and I will click that little thing, you can copy and paste this image and you can copy it into a Word document and it looks beautiful. It looks a lot better than what an Excel would look like. But you can also play with this. So you use tomatoes, right?
Yeah.
So let's do appearances. You don't have to use tomatoes. Let's see. But they'll let you choose something other than dots. I don't know where that option is, but this, oh, here, right here. You can use, not a data emoji. I don't want a data emoji. There's some alternative, and I don't know where it is, but there's one on here where you don't have to use dots. You could do something else. But you could choose different colors since you use tomatoes. Maybe you want to make the dots red. Okay. You can play with it and make it look pretty. Yeah, and all these things will allow you to do that. Trying to think of what else you should do. Oh, see this data right here? Include that on graph. I'd do that too. And then I'd add a title. It does let you add title. And you could put a title on this graph. So tomato, what would you title this anyway?
pH. Wait, humidity's effect on pH for tomatoes.
Humidities. Yeah, humidities. Actually, humidities. Effect on pH over. Yeah, that's it. Just a pH on, and also use this on the species of tomato. Like, what is the scientific name of a tomato?
I do not know. I'll look it up.
Well, I'm just saying that's something to do because, and then you could put the species out here, whatever the species is, right? You just type it in there. You can make those changes. So that's done. But when you click on this now, you'll score another mark. There's another mark you score because you have statistics already here. So I'm going to copy this image. I'm going to go to a Word doc, and then I'll show you what it looks like on a Word doc. You can't see me change to a Word doc yet, right?
Mm-mm.
All right, so I'm going to go back. Look at this dog. I forgot your dog's name again. What was your dog's name?
Lambo.
Oh, that's it, Lambo. Lambo. I'll show you my dog. Look, come here. Look, come here. Is my camera on? Yeah, my camera. Yeah, come here, Riley. Riley, come here. Come show her friendship. Look, friendship.
Aww.
Look. Oh man, she's got to look at this dog. You see that dog? That dog has friendship too. That dog's in Friendship Town. You want to go to You want to go to Friendship Town? Oh my goodness! All right, beat the street. Go beat the street. All right. So I'm sharing this Word doc with you now, or not?
Yeah.
So now I'm going to right click. Add your. There's all of your graph. Let me actually change that. I'm going to go back. It won't let me write a line anymore, but I can make it a little bigger. Now, the other thing that you could do is make a data table. In the data table, the only thing I would use, you could literally make your own data table below it, and you've got group, and see how it's nice because it has group, right?
Mm-hmm.
Because you could put group in, and in your group, your own data table that you make on like Excel, and then put it below it. I'd put group, and then I would put in parentheses pH, lowercase p, uppercase H, 0, 20, and then it gives you the average for one, it gives you the standard deviation for one, it gives you standard error, the mean for one, and these are all good writing prompts.
All right.
All right, before I do anything else, and you're probably thinking, Jesus, I did not expect to get all this information. At least if you have any sense, is what you're thinking. Like, I wasn't gambling on this. I'm trying to do technical Bram Stokes Dracula. Are you going for the diploma or are you going for just certificates?
I'm trying to go for the diploma.
Oh, well, then you've got to get this square.
Yeah.
Yeah, then you have no option. You're gonna have to write about how why your data was insufficient. You got a lot of stuff to do.
All
Um,
right.
let me go back to your table. Okay, so preparation. Let's see how prepared your data is. There's something here. It says if you want to, it'll sometimes. This is no description has been entered. This is all out. Yeah, you can change this, but you just put on here ignore for now. Everything else looks okay. So let's continue. Visualization graph. It's all you've already got a graph, but you can open up Graph Wizard. There's things that it allows you to do. You can play with and see if there's something else that you want to play with. There may be something else that I'm overlooking, but you can say yes, 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 and see if there's anything else that you might be able to pull off to get an extra mark. Maybe.
Okay.
But what I did is instead of using graph, I clicked on table. And then I can start. This is the ANOVA. We already did that anyway. But this is something you can include on your test. See how that says right? This this camera. Copy and paste this and put that into your. See how it even has your F statistic. This is your degrees of freedom. It calculates all this for you. And these are good writing prompts. They're really good writing prompts. Okay. Interpretive analysis. There's something wrong here. Let's see. Select. Let's see if it'll let us run a t-test. No, it won't run a t-test. You can only have 2 values for a t-test. So nope. Let's try to run a chi-square analysis. It's not going to do it. Yep, you don't have enough data for it, kid. You don't have an expected. You don't have an expected value. What we've done is probably all you can do is run the ANOVA, but at least it gives you a p-value and it gives you some other things to do. Let me go back to your paper. I might just be able to switch this screen over. What did you type your? Did you type this or Abunu type this?
We like worked on it together.
Okay. What did you guys type this in? Word,
A Google Doc.
a Google Doc. Put it in Word because there's some things in here that there were some typos in here that I saw. And I was like, what? Like I read it and I thought maybe I was crazy. And then I wasn't. It did read the way I read it. Let me see. Where was it? Oh, right here. Check this out. You said the levels are a humidity of 0% form original, 20% form original, and 40% from original. So that Google Doc just saw form is a word, but it doesn't tell you if it's the appropriate word.
All right.
So if you make mistakes like that, it'll catch them for you. I would also try to increase my academic language. I wouldn't say decay. I think I'd say decomposition. Somewhere in here you said rot. Maybe you could write instead of rot, you could say decomposition or decaying. I would try to use decay and decomposition, both of those for the appropriate grade level. Tomatoes, you need the scientific name for tomatoes. I don't see any sources cited in this. I don't see any sources cited in this, even though you have sources down here. In fact, when I read this, I was like, damn, did they use any sources? And you did. The bibliography looks like you've got 5, but there's no direct citation in your paper. You'll get crucified by IB for not doing that. I mean, big time. You do. Oh, here it is. Fermentation is an exergonic reaction, and there should be increasing the temperature. That's what. Yep, there you go. But you barely mention that. You barely say, okay, give us a source to back that up. That would be excellent. for the formula for analysis of variance in your analysis, you should have a formula included. And here, again, this p-value that does not make any sense at all. You got to get rid of this. Here's a formula, and this is the formula for what?
That was the test she used, the t-test, but I didn't recognize it when she showed us.
Yeah, but it's not appropriate for that. So you're going to have to put, what you do, you would put a formula for analysis of variance. And then you have so an ANOVA test. And I'm going to drop it in the chat so you know what I'm talking about. Look, what? Are you talking to me? Why? Well, it's a Saturday afternoon. He's working in the yard. Give him a break.
It's annoying that I have to compete with our neighbors.
Oh, mama. You hear her grappling? Sorry about that. That's the ANOVA test. So put the formula for ANOVA test. I'm going to go back to your paper again. You can't see me looking at your paper, right?
Yeah.
Do some, see that rotting? I might put rotting. And you do have some qualitative data. That's good. Your conclusion, due to system there's above 5% and level was not such that the null hypothesis decline. You only decline, meaning accept a null hypothesis if that makes sense. This actually makes sense as to the way it's written, but I wouldn't put it in a percentage form. I would put it in 0.05. But you didn't get a 0.05. You should put your actual p-value 0.46. So it's not significant. So you accept that there's a null. You accept a null. There's not, everything's random. What you guys have is just random. And also, do you see this word correct?
Yeah.
Don't use the word correct. Use the word supported or unsupported or rejected or accepted. You never say correct. You never say prove. Never use that. That's bad language in science. Bad language. That's potty mouth language. You can't say, because let me ask you a question. Do scientists try to prove or disprove?
Prove.
Okay, they don't. A scientist tries to disprove something, and if they try to disprove their hypothesis, and if they can't disprove their hypothesis, they accept I'll accept it then. I tried to disprove my own idea, and because I can't disprove my own idea, then I'll accept the whatever result I get. That makes sure that you don't have a bias. Science is the most unbiased thing that has ever been known to man. It is completely objective. It is not subjective. And in order to remain objective, we try to disprove and not prove. Because if I wanted to prove that my dog is the best dog in the world, I would say dogs that are the best dogs in the world will have curly hair, blonde hair, be 65 pounds, and smile when you say their name. And that's me having a bias towards my dog.
Mm-hmm.
But scientists don't do that. They always try to disprove, not prove. And when you can't disprove something, then you accept it. So when you say the word correct, your hypothesis was correct. That's just not the way that we try to say it. So just want to remove that language. I really don't. Here's your weaknesses. So let's say weakness can be affected in the data. Start off the container in order. Saying this is most scenario. Further dive in the data. Another major weakness: the fact that tomatoes do not have a range of temperatures. Okay, I think what would you say your biggest weakness is?
We don't have enough data.
Yeah, your sample size is the biggest weakness. You're going to want to include that in there. At least you'll get a point for explaining that. You're going to lose points in your analysis already. And because your analysis is going to be weak, your conclusion is going to be weak. But you can come back and talk about your weaknesses and recover a mark. And at this point, you're trying to get every mark you can. Okay, and on your extension, talk about what you would need to do to correct that, right? Like increase your sample size, sample size of 30 to at least 30. That way you can actually run a t-test. And only 2 groups. You would only have 2 groups. You would do it at 0 days and 5 days. If you only had 2 groups, you measured only at 2 times, then you would have enough data. Now you do have the opportunity, and I'm not joking, to go to the store right now, buy 60 tomatoes, but do you have the instrument that you could record 30 data points?
Probably not.
So that hydrometer that hydrometer isn't something you can put in 30 different times or anything to control it. All right, well then you can't. But you could write about what you could do to correct this and your weaknesses and extend this. And that would help. Now, Mr. Diaz is not giving you any more content, right? It's just I, right?
We're like this week is IAIA, and then once it's turned in, we're reviewing because I think he's still having a final based on our content.
Yeah, I might get that. Yeah, so you've got all week to focus on this. What other IAs do you have out?
We have history, Spanish, English, and
of those, how many are you done with?
History is just going to take me like an hour to do, and then Spanish and English you have to do like with the teacher. You're like talking.
Okay. So that's easy.
Yeah.
And so you also like here on this one, because your sample size is so small, you're looking at hopefully getting a 3, miracle that you get a 4. So you really want to try to get this. You know that it's an average to get the IB diploma, right?
Mm-hmm.
So, but you can't make a what. If you make a what, you're done with the IB diploma. What would you have to get on one of your IAs that would eliminate you from getting the diploma?
Because I know for HL you have to get at least a 4. So I'm
probably for HL you have to have at least a 4 in all of them, or you have to have an average of a 4.
I thought it was 4 for all of them, but bio is my SL. So would I have to get at least a 3?
You have to get a 3. If you do not get a 3 and you get a 2, which if you turn this in right now, I would grade it at a 2. I would literally. What did he give it?
He gave us a 5.
As turned in?
As turned in. Well, he said it would be automatically failed because it's way too similar. But he said
done.
Yeah, he said without the similarities, it would have been a 5.
Wow, I'm surprised because when I look at this data, I'm looking at it going, what in the world? Because I don't understand what this total is. It doesn't make any sense. I don't know how you got these humidity levels to be so crazy. I mean, what does this mean at this point? I'm not sure what that.
I have no idea.
I don't either. Honestly, when it says 0% day 1 Celsius, you got Celsius here, but I don't know what that temperature is. I don't know. It just says Celsius. And I honestly don't know what that means. Unless, I really don't know what any of this means. I just looked at this. I don't know what this is. I'm assuming that, like if this is your independent variable, this humidity, this needs to be on in this row. You would have humidity 0, 0, 0. I would have up here humidity in percentage, just like what I was showing you before. I mean, I'm gonna go back to my Excel spreadsheet that I had. Hold on a second. So you need to arrange your data in this format so it makes some sense. So here, your independent variable here, and you've got humidity 0, 0. As many times you did 0, as many times, whatever humidity level. So you keep your units up here. There's no reason to put units in these cells. This just needs to be numeric. Your units are going to be title. So humidity percentage, pH, that is your unit, right? And then this all needs to be numerical. You have your other This is your other one. Let me go back to that. I did the same thing with this one. I did day at percentage. I mean, you could do that. Now, the cool thing is you have different days. I only did 20%. You could go back and do 0, take your data and arrange it in this format because you have 0 and 40, and you might get a significant result at 0 or 40. I don't know. I just chose 20 just to show you an example. And I was doing it every 72 hours. So I was assuming this is 24 hours, 72 hours later, 72 hours later, and so on. You could do it however you want, and you play with it. You might get a significant effect. I don't know. But I would do at least 3 graphs. I would have a graph for 20%, a graph at 0%, and a graph at 40%. So I'd literally graph that. I get that. I would make several graphs on Data Classroom, and your graphs are pretty. You're going to get a couple more marks. So how he gave you a 5, I don't know. That might be my bias, but when I look at your paper and I see data tables that I can't make sense out of, if I were reading it, I'd be like, what are these kids doing?
Right.
And I would not give it as high a score. But yeah, nobody needs to write anybody else's paper at all.
Okay.
Because if they see that, yeah, you're done, 0. Everybody needs to write their own thing. You can do an experiment together and you can use different dependent variables, but nobody needs to write anything for anybody else, because if they come in here and they even see like temperature, parentheses, air conditioned with different humidity, ooh, they're going to be like, what? These kids are cheating. Done.
All right.
When are you going to get this done?
I'm trying to get it done by Wednesday.
All right. Well, oh, my battery's about to die. I'm pretty much done with everything on, let me think. I have my kids Tuesday. I'm pretty much done with everything on Thursday. So if you want me to take a look at anything else, I could look at it again on Thursday. I don't know. And I could just give you a couple little tips and that would be the end of it.
All right.
I'm sorry if I gave you way too much information here, but there was a lot I would change.
Oh, no, it was perfect. I took down notes. I got most of it.
By the way, I'm just looking at something else. He's got vitamins like C and K. What's is that supposed to be vitamin C in vitamin K?
Yeah.
I capitalize K and C.
Okay.
I do that. I think if you put this stuff in, if you write this in Word, it's going to find those little things, and instead of saying this will help, I'd say this would assist. Just try to look at this and think what synonyms that you could get so that your that writing part on the end of it, your communication part, try to score those points as much as you can. And just using synonyms is going to make a difference.
Okay.
All right. I don't know if I recorded this. If I did, yes, I did. I'm going to download this. I'm going to put it into YouTube, and then I'm going to send you a link to YouTube. So if you want to review this video, you can.
All right. Thank you.
Welcome. I'm going to let you go.
All right. Thank you so much, Mr. Pope.
You're welcome. Tell Lambo, what does Lambo do? Does Lambo have, does he do something fun?
No, he just sleeps around all day.
He doesn't retrieve or catch Frisbees or anything?
No, because like when we try to play fetch with him, like he'll just take the toy and run.